right, Precal. This is going to be 5.3. I think this is part 2. Yeah, let's go with that. This is more of solving trigonometric equations. Man, y'all sure do take your sweet time getting to these assignments. Y'all have been the last group to get your work done for my classes. Okay, so let's see. This is example. We left off, I think, on example 3. We did some factoring. If you want to follow along in your book, I am going to work these two from the book. I don't know if that's helpful at all to have your book with you, but I'm on page 365, and this is example 4. Next week, you guys are going to have to be on top of things a little bit more. I guess I should say this week if you're watching this video. The first assignment is due Tuesday this week. Okay, so we're going to solve, I'm just showing you more ways to solve these equations. There's all kinds of ways you can use any number of these strategies. We looked at factoring, we looked at collecting like terms, solving by using square roots. So today we're going to look at another equation. I think this one we're still kind of factoring in this case. Yes, okay. So let's say we had here 2 sine squared x minus sine x minus 1 equals 0. And in this example, in this case, they're asking to find this on the interval of 0 to 2 pi. Now what that means is just find the solutions from 0 to 2 pi. So you don't have to do all that business of adding, remember, the 2n pi. So you don't have to find the infinite number of solutions, just the ones that are on the basic unit circle. It's the same condition on the quiz that I'm having you do for 5.3. You just have to tell me the solutions in this interval. Okay, so for this one, I'm going to try factoring first because I think we can factor this. Sometimes you can't factor. I'm not really going over it in this lesson, but know that your last resort is you actually can always use the quadratic formula as well, but we're going to kind of skip that for this lesson. Sorry about that. Okay, so we're going to factor this. If you prefer to rewrite this, if this is a little confusing for you and you want to rewrite it as like 2x squared minus x minus 1 while you factor, that's fine. If that's a little bit easier for you to deal with, and then go back in and add your signs. Because if we were to factor this, all right, we have to split up the 2x squared. Thankfully, there's only one way to do that, 2x times x. And then we have to split up negative 1. Well, that's positive 1 times negative 1. We just got to figure out which one goes where, because we have to get negative 1 in the middle. Well, if I put negative 1 here, these two will always be multiplied together, and these two will be. So here I get positive 1x, and then these multiply together, and I get negative 2x, and I add those together would give me negative 1. So let me rewrite this with our sign. So you would have 2 sine x plus 1 times sine x minus 1. Now we are factored, and we're going to solve each of these little equations separately. So 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. Subtract 1, we get 2 sine x equals negative 1. And then sine x equals negative 1/2. And over here we get sine x equals 1. Now again, you can just, if you want to get out your unit circle or your chart, you can do that and look at where is sine x equal to negative 1/2. I always like the challenge of trying to find that on here. So 1/2 is the short side. I think of that, I always think of the 30, 60, 90 as the short and long sides. So, and sine refers to y. So when y is the short side and it's negative, it's down here. So it's a sixth, right? Because we've got 1/6 all the way. So this would be 7 pi over 6, and then over here it's also negative, and that would be 11 pi over 6. So those are the two places where sine of x equals negative 1/2. So x equals 7 pi over 6 and 11 pi over 6. And then we also have the sine of x equaling 1. Well, right up here is when the sine of x equals 1, sine is y, and that right there on the unit circle is pi over 2. So that is our third solution. Good? All right, let's do another example. All right, we're going to do example 5. I feel like I'm going kind of fast, but you know, y'all can always pause, so. All right. This one is, okay, so this is the strategy of rewriting with a single trig function. So if you were to have something where you've got multiple trig functions in one, like they're not all sines or all cosines, sometimes you can convert them to the same thing. So here I've got sine squared, but I've got cosine. So it'd be better if they were all the same sign, right? So if we change sine squared, we know that sine squared equals 1 minus cosine squared. Now, if you don't have that paper I gave you, this is the back, not the very back cover of your book, but right here, second to last. You have all the identities here, and we have here sine squared plus cosine squared equals 1. Well, you can rearrange that so that sine squared equals 1 minus cosine squared. We're going to use that identity. So we'll change this into 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. There's lots of different ways you can go about solving these. So I'm just showing you all different kinds of strategies because sometimes one way is easier than the others. All right, let's multiply. So 2 times 1, we get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now we just combine our like terms. We've got a 2 and a negative 3. That becomes negative 1. What is that? Why did I write a C? Is that supposed to be an X? Oh my gosh. It's a Friday night and I'm doing pre-cal videos, so That's how I'm doing right now. Minus 1. All right, now we're at, this kind of looks like a quadratic that we could function, right? X squared, x constant. So I'm going to try to factor this, but before I do, this is just another little trick. I don't like having a negative out front here when I'm trying to factor, like a negative x squared. I don't like that. So the trick is if you just divide the whole equation by -1, you can change all your signs and that goes away. Remember, whatever you do, if you do it to everything, it's okay. So this becomes +2, this becomes negative, this becomes positive, and 0 just stays 0. All right, so now let's, again, these are the yucky ones to factor when they have a number out front, but this one shouldn't be too hard. So to split up 2 cosine x squared, you have 2 cosine x times 1 cosine x. And this is what's great about this, is there's only one way to factor this where you would get a negative here, right? Because 1 could be 1 times 1, or it could be -1 times -1. And since this middle term is negative, we're going to go with the -1 times -1. You don't even have to work it out because that's the only other option. But if you wanted to check these two, -1 times cosine gives me -1 cosine, and then 2 times -1 gives me -2. -2 plus -1, -3. All right. Now we set up our 2 smaller equations. I really do miss y'all. Even all your craziness. It makes me really sad not to be able to be in class. Alright. Now divide by 2. We get cosine x equals 1/2. And oh, this one's done. Okay, so again, you can look at your circle. Let's see. Maybe I'll pull the circle out. I have it over here. I think. Do I have a full unit circle? Ah, there we go. So we're looking for where cosine x equals 1/2. Remember, cosine is the x value. So right there. And then it should also be on down here on this side, right? And right there. So 5/3 and 1/3. You could say, sorry, pi over 3 and 5 pi over 3. And then where does cosine x equal 1? Well, that is when you have right there, right? At 0. Now, you could say 2 pi, but look at this one also, I believe, asked for, oh shoot, my book closed. Let me just double check. I think this one also asks, how did I say ask? That was weird. Oh, well, no, that one didn't ask for us on the interval. But let's say this had asked for that interval. When you saw that interval 0 to 2 pi, it looked like this. So that meant 0 was included, but 2 pi wasn't because of the parentheses. So you would just use 0. You wouldn't use 2 pi because that parenthesis there means it doesn't quite get to 2 pi. All right. I have a couple of just little hints I want to give you on your homework. And then I think we're finished. the first one, both of them I think are mostly just about secants and cosecants. So if you see that, I'm sorry, I keep saying All right, let's say you got down to the cosecant of x equals, like you solved your equation and you got the cosecant of x equals 2. And you're like, well, what do I do with that? Okay, remember that the cosecant and the secant, they're reciprocals, right? The cosecant is the reciprocal of sine. So if the cosecant of x is 2, or we could say 2 over 1, then that means the sine of x is 1/2. And we know that this is on the unit circle. So you could then go find that. The other thing is, if you get to, if, I say if, which you will, so let's say we had like the secant of x equals 0. Again, this is a reciprocal, so you could say 0 over 1, right? If you were to then flip that and you're like, okay, well, I know cosine is the reciprocal of secant. If you were to try and flip this, you get 1 over 0, right? Which this is a big no-no. You can't have 0 on the bottom. So that means that this solution there isn't a solution here. This one doesn't exist. And you'll probably have another half of the equation, but you get to here and you go, nope, that side doesn't have a solution. Okay, I think that's it. And you do have a quiz over 5.3. I'm hopefully going to have a little video for you about how to do the quiz. I made it in Google Docs, so you can go in and you can edit it and you could submit it that way. I'll show you how to use some of the equation tools in Google Docs. Y'all are smart, you may be able to just figure it out yourself, but I'll take it in many forms if you submit it. If you just want to print it out and write on it and send it back. I really only need your answers. I'd love to see your work, but again, if you're just going to edit the document in Google Docs, you can just type in the answer. Okay, bye guys.